So, my name's Sean, and I teach kids about computer science and video game design down at William J. Palmer High School in Colorado Springs. And we've been working on a couple of different projects, and our project for the beginning of 2024 has been to look at real-time satellite data that is being hosted and provided by a company named BlueStaq, and to take that information and to try to create a holographic visualization of that real-time satellite data. And for the most part, what I'm about to show is stuff that I've been working on, but I have had students kind of helping along the way think through like what would be some good things for us to work on. I also, though, have been trying to figure out how I could teach kids how to do the same kind of thing that you're about to see. So we're going to go ahead and we're going to do a holographic remoting. We've put this experience into a broader experience that we've been working on. And you can see that I'm sitting in my classroom and we're waiting for the data to come in. And it's taking a little while right now because what it's doing is it's actually making a call to the database that was created by BlueStaq to pull the real-time satellite data. And so if I walk over to this button right here that says Gravity Sim, and I go ahead and I click on it, and I look over here, you'll see that we have different satellites that we have that are going around the Earth. Now, we didn't create all of the coding for this. The coding for this was from a Unity asset store asset called Gravity Engine, and it has information about how to visualize the orbits of satellites. However, the actual information that is populating this so that we can see those satellites, that information is actually coming directly from the unified data library that BlueStaq has put together. And it is stuff that we were able to go in and that we were able to grab. Now, these orbits that you see right here, obviously the scale is not correct. We scaled up the size of the satellites, and some of the distances between those satellites and the Earth are also not correct. But it gives an accurate set of orbital paths, at least based off of the calls that we did to the database. We have the ability to reach out and to turn on or turn off different satellites, and to just look at certain kinds of orbits or look at certain kinds of satellites. So we could do a comparison between these two satellites and talk a little bit about how these satellites not only are orbiting, but how they're being used by NASA. All of the satellites that we're working with right now are assets that satellite assets that are from NASA or are the International Space Station. But we can go and we can use the satellite numbers in order to populate additional orbital paths if we have other satellites that we would like to be able to take and put into our space. One of the other cool things that we've done so far is we've actually gone to the NASA site and we have the NASA models for these particular satellites. So this isn't some random, model of a satellite. This is actually the NASA model of the satellite. Now, the orientation of the satellites, we still have to figure out how to get the orientation to be correct, and we have to figure out how to create some opportunities for us to be able to interact with these. But you can see that if I was to come around to the other side of the world here, and I was to look at the Calypso satellite that's in here, you can see that it has texture information and stuff for the different satellites, so you can see the different pieces. One of the ideas that the students are kind of playing with right now is the idea of being able to click on a satellite and have it bring up a life-size version of the satellite in a slightly different visual space so that you would be able to inspect it and to use some coding that we've done in the past where we can take a 3D model and we can split it into component parts, and to potentially take a satellite like Calypso here and make it so that we could split off the solar panels and have information about the solar panels, split off the main body of the of the satellite and potentially split off things like the thrusters. But the most exciting part about this at the moment is that we have real-time data that's being fed in through a database call and is being parsed so that we can get the TLE information about the satellite orbit, and then taking that and putting it into an established resource that kind of helps us visualize what those orbits are. But students are starting to have conversations about different kinds of data processing, but also about different kinds of terminology related to space and satellite flight. So pretty cool to have that be something that we actually got working today, and thought that I would share.